Okay, there we go. Sorry, some technical issues, I guess. Oh wow, sorry, my bad. I just received a comment that there is no sound in the picture, so I hope it goes now. Yeah, just a quick recap. We're gonna be modeling this shape today. This is like a pavilion, which is created from a double curved surface and basically made of timber bars scaffolding on top of it. So let's start. We're gonna talk about the data management principles in progress and in process, and yeah, let's move on. So first of all, we need to create the profiles for this pavilion, which will form the base shape, and I'm going to show you how to do it with instead of making these three curves independently in Rhino or in Grasshopper. I'm going to show you how you can do it in one single data stream. So let's make a range to create a number of the points. Let's say 15 points should be fine for us to have this. Actually, 16 points should be fine for us to have this smooth and clean geometry. So we basically need to have three curves, one in the center and two on the sides. For that, I'm going to use the entwine component to provide the data for two of them. Sorry, for three of them actually. I'm going to construct domain with the first of all, we're going to move the points in x direction, so it's quite important to define the dimensions of the shape of the pavilion. So the sidemost curves are going to start from 0 and go for, let's say, I don't know, 300 millimeters, let's say. Oh, sorry. Yeah. Go. It will go here, so that you see we get 16 values in the domain from 0 to 300. Let's connect them here and here and here. Yeah, so you can see that basically we get this. Actually, we can go even a bit more. The pavilion can be even 400, let's say. If we're trying to keep it in a more or less realistic scale, we can make it yeah, 400 millimeters. Okay, so then we're going to make the central curve, which is going to start a bit earlier and finish a bit later, so it has to be longer than this. For that, I'm actually going to create another range component with the same amount of points, and for the domain, I'm going to we can either extend domain. Is it called extend domain or not? No, I think it's called. No, never mind. We're just gonna multiply this number by some other factors. So 400, I'm gonna multiply it by, let's say, 0.5, and I'm gonna go with a negative, so that's the central this. Yeah, and then for the upper limit, I'm gonna go with multiplication by 1.10, let's say, something like this. And actually, this slider, instead of using this slider here, I'm gonna connect this number to this slider, and this is the new domain for the. Yeah, you see that basically now we get the next curve, which is going to be the center. Right. Then we need to do a similar operation for y, because yeah, because basically y needs to be moved as well. Yeah, let me organize this quickly a little bit. So keep it like this. So yeah, basically those domains are here. These values are here, and with that we are kind of set more or less. So yeah, so that's it. Okay, fine. Let's go. Let's move on. Let's take the. Let's now change the y direction. So for that, we're going to use the same range, but this time we're going to use different domain because we need to have have them growing not linearly, but following the graph. So we're going to use the graph mapper, and as like the most popular graph, I'm going to use the Bezier because it's like let's say most easily controlled one. So let's say that we remap numbers, we create bounds for the numbers for the correct remapping actually, and then we're going to use the construct domain. This time I'm going to move the points by a factor of from 400. So let's take this number again and this. Let's multiply it by I don't know, for example 0.25 maybe to start with. Maybe it's a bit too much actually, but whatever. And then we can also multiply it by let's say 0.08, sorry. Yeah. Let's construct the new domain. So why am I doing it through multiplication of this initial number is because I really want to make sure that we can scale our pavilion without changing its proportions easily, and we can basically do it with only one slider. And then if we need to change the proportions, then we need to change separate sliders. Yeah. So all right, then we take another entwine component. We connect this number to the 0th branch, and the same values but with negative sign to 0.2 stream, right? I mean data stream, because we need to make sure that our pavilion is going to be symmetric. Yeah. And for the central curve, we just connect 0 because we don't need anything. We don't need these points to be moved. Yeah. So as you can see, our pavilion starts taking its shape. Yeah. Well, maybe it's a bit too extreme from here, from this side. I'm gonna keep the lowest number at 1, and here I'm actually going to increase it a bit, so that it's going to be a bit longer in the beginning. Yeah. So here maybe we can shrink it a bit to, let's say, 0.20 maybe, something like this. And yeah, of course the shape can also be slightly changed. We can make it a bit different like that. Anyway, this is like the plan of our pavilion. Now it's time to change the z coordinate. So the way I'm gonna do it, I'm gonna, instead of using 3 graphs for 3D and even 2 graphs for 2 different types of curves, I'm gonna use 1 graph. And let's take the let's actually just take these 1 second. Let's take basically we need to make sure that different curves will be moved a bit differently. So how about we make How about we make this the first and the last curves symmetric? We make them the same, and the central one we will slightly change it. So okay, let's actually take two graphs because we have two types of curves. So let's just for the sake of simplicity, let's take two of these graphs. Like this. So we will also have more control of the geometry, and then again we take the same. Well, not the same, but like a similar setup, and we use it as a new domain. So we multiply 400, like, okay, the side curves, they're gonna start at 0, and they're gonna go up to, let's say 400 times 0.50 something, I don't know, like that. So they're gonna go pretty high. Again, we're gonna do the same thing here, but instead of using negative, we're gonna use the same value. So we're gonna connect it like that. Yeah, this one we're gonna move it here, and let's make, yeah. And for the central curve, we're gonna put different values. So instead of starting from 0, the central curve will start from, again, some factor of 400 millimeters. So let's say it's gonna be it's gonna go from 0.40 something to maybe 0.60, because the central curve has to be a bit taller than, sorry, a bit higher. It needs to go a bit higher than the side curves, yeah. So it's gonna be like that. Yeah, and then we connect these values to z. So, oh wow, that's a bit too much probably. You see that it goes really high, and here we need to change the shape of the central curve. I'm also gonna move it significantly lower, and here I'm gonna go a bit higher. So it's a bit, it has a bit so the curvature of this shape is gonna be a bit more extreme, yeah. So something like this, maybe something like that. And here maybe it's a bit too much, so maybe we can make it a bit calmer, let's say. And here, instead of having it at 0.56, we can move it a bit lower, something like this, yeah. So you see that basically with these graphs, we already have a pretty controllable shape, where everything relates to the initial, where everything depends actually on the initial parameter, which is this. So you see, when we move this single slider, we change the scale of the shape, but not the proportion, which is quite important, right? And then if we want to change the proportion, we can go independently to each of these sliders and yeah, and start playing with it. Yeah, see. So I mean, this setup doesn't seem really, let's say, really laconic, but it gives us a lot of control over the shape, and also it's yeah, basically instead of making each curve individually and having to change it and control it by hand, we can just have it all parameterized, and after all, we have just the points here, right? So after that, I'm actually gonna hide the initial construction plane. We don't need it right now, so I'm gonna make it a bit more, yeah, let's see. Okay, looks good. Well, I mean, I guess it's not bad, so let's make it a bit more lower. Yeah. Okay, so now I'm going to build to start creating the curves. So let's interpolate those points. Oh my, here it is. Let's interpolate the points, and yeah, as you can see, we get this let's say the railings. And then I'm going to, because like if we build our surface right now, if we create a loft, let's say we flatten it, again, I highly don't recommend you to ever flatten anything. but just for the sake of simplicity, yeah. You see that this is like, okay, it looks not that bad, but I think we can have a more, slightly more controlled way of making it. So what I would recommend is to divide these curves again, right? Why do I suggest dividing it instead of using those points? Actually, it's interesting though. Does it? Yeah, you see, those points, they are not the same, right? Because when we construct the point, we move points up and to the right, to the front, or to the back, right? So yeah, basically it doesn't they don't get distributed uniformly along the curve. And when we divide the curve, we make sure the points are distributed equally, right? So that this method is going to be a bit more precise to build the profiles. So let's use the flip last component from Heteroptera plugin, which I highly recommend everyone to install. And you see that now each of our branches consists of 3 points. So it's like this. So it starts going. We start making transverse sections, right? So let's interpolate them. And you see we get this kind of profile of these sections, right? Which, in my opinion, are a bit yeah, they are a bit more controlled and a bit more clean than if we make a loft through these 3 curves. So now, if we want to create a loft, I suggest us to shift paths, yeah, instead of flattening, because let's say if we want to have multiple pavilions in one script, we cannot flatten them, right? We have to shift paths, so we go one level, one tier of the tree below, but yeah, we get similar result, but with can be applied to multiple multiple tree branches, let's say. Okay, so we have our initial geometry right now. It's quite precise. I'm quite happy with it. I mean, it looks good to me. You can change the shape and make it completely different. For example, we can make a lot of different things about the shape and also the profile of it. So it's up to you, guys. But yeah, I'm gonna use the shape for the sake of demonstration. So now we need to create 2, because our geometry is going to be made with kind of overlapping wooden bars. So that means that we need to make sure we have 2 levels of those bars, and that they intersect, they kind of overlap with each other, right? We're not going to touch the aspect of detailing, connections, and connectors in this session. This is a really long and quite complicated process, but we might consider doing a course or a tutorial about it in the future. By the way, please drop us a comment if you would like to see let's say in detail tutorials talking about fabrication and how does the complex geometry relate to the process of making it, right? Okay, so right now we're going to talk about the conceptual stage and how can we make this like how can we make a robust and fast script for the conceptual stage of the design. So let's start with making the offsetted surface to make sure we have two levels. So right now, let's say the section is going to be also related to. Well, actually, the section does not need to be related to. I mean, it does, but for the sake of having the absolute value instead of having a relative value, we can just type something like 50, let's say, for the thickness of our layer and for the thickness of the wooden bars as well. And let's say we will offset the surface by the same amplitude. Oh wow, that's a bit. Oh no, sorry, it's not. Should not be 50. It should be 5. 5. 1 second. So it's 400 millimeters. sorry, my bad. It's 400 centimeters. Sorry, I know we normally work in millimeters, but here we can work in centimeters just for the sake of not having too many divisions in our sliders, which is not very convenient to move. Okay, so let's say it's going to be 5 centimeters, which seems fine. Just 40 milliseconds, which is fine. I just want to make sure that my surface gets offsetted in the opposite direction. So I'm going to put a negative here. I want it to go out, not inwards. Yeah, I mean this looks okay to me. So let's proceed. Maybe instead of having it 5, I'm gonna make it 2.5. Let's say. We will see. Maybe we can make it more or less. Let's see. But this slider is very important because it's going to be the dimension of our board, so it's really important to keep it here and vision. Let's see. So then I'm going to use the populate geometry component to create the. Actually, gonna hide this. Actually, let's entwine those surfaces because our scaffolding will use a similar logics, so we can just entwine those two surfaces. What is important now is to make sure that those points, they do not kind of, how do you say it, they don't match, because we actually need to make sure that they will overlap, right, instead of just going in the same direction. So let's create different seeds for our two shells. Let's go for 3 statistics. Let's connect it here like this. I'm gonna make a random seed generator. So random, this one, the default grasshopper component. I'm gonna connect count to m, and for the range I'm gonna set the seed to from 0 to 200, let's say. So it's gonna be really different. And then here we can create another slider from 0 to 100 to control the seed for the seed generation, let's say, right? And here we need to graft it, yeah, so that we make sure that we have 2 sets of points on 2 different layers. And here, for the number of points, I'm gonna go a bit higher, let's say 150 maybe. Looks fine to me. So, and let's start with creating the basis for our wooden bars. Yeah. So let's go for surface closest point to get the UV parameter of each of those points. So we're gonna take those surfaces, those points. Then we're gonna say evaluate surface to actually get the planes which are going to be located on these surfaces, so something like this. And you see that basically we get those planes. And what is really nice about this approach is that the axis of those planes, they follow the direction of our surface. So right now we can actually create the curves, right? We can create the curves for those planes, like, well, not curves but like lines, because the bars are going to be straight. So what we can do, we can say deconstruct plane, right? It's here, it's in the frame output of the evaluate surface component. So you see that the red axis is the x-axis, right? So we can make sure that these bars will follow the x-axis, and then we just say move. So actually I'm going to graft those planes, and then I'm going to move each point. I'm going to move it in 2 directions. One is going to be following the y-axis, the other one is going to be I mean, it's also going to be parallel to the y-axis, but it's going to be with a negative sign, so it's going to be going in the reverse direction. And then I'm going to type the amplitude this is going to be a vector, and for the amplitude I'm going to create another slider, let's say something like 40, maybe a bit less, 25 maybe. Let's see how will this look. Okay. Actually, sorry, is it? Yeah, sorry, we were talking about x-axis, so it should not be y, it should be x-axis. Now it's correct. Now it goes along the geometry. Okay, so now let's create a polyline through these 2 points, because you see in each branch we have 2 points. And if we switch off everything, you see that we get those curves which are parallel to the surface. If we increase the density, like if we increase the number of population, we can get something which looks like a woven or threaded geometry, which is also kind of nice. I mean, it looks not bad to me, but that's not what we want. We want to make sure that they overlap. So maybe I'm gonna really keep it a bit denser, but at the same time, I really want to make sure that these polylines start rotating and start overlapping and building this kind of scaffolding thing. So how can we achieve this result? Well, I mean, we're not talking about in this particular session. We're not talking about how do these wooden bars follow the stress lines or the pressure this shape experiences. But of course, if we're talking about further steps, it's very logical to make sure that we can control the direction of those bars, because they have to respond to the forces and to the stresses of the structure, like for example to bending forces, to compression, tension, and so on, so on and so forth. So right now we're going to like simulate this, like replicate, let's say, this behavior instead of making it properly. But I'm going to give you the let's say I'm going to give you the procedure of how to do it from the data management perspective. So how can you do it? Which tools, which Grasshopper tools should you use to have control of the rotation of those wooden bars? So let's take those frames and let's rotate them. It's quite convenient because we're going to rotate those planes in those planes. Just important for us to set this 2 degrees. And now we also need to make sure that the curves will rotate here, but they will stand still along the railings, yeah, like these 2 railings. So let's take the brep edges component. Let's use those 2 breps, right? And let's take the naked edges. So we can actually just join them. We can say join curves. Or actually, which I think makes a bit more sense, because on top we also don't really need to rotate them much. We need to keep this kind of profile, so we can also take those curves. Sorry, those curves, yeah, the, let's say, longitudinal ones from here, and we can just use them as the attractors to control the rotation of our wooden bars. We can again, we can shift pots here. Okay, sounds good. And then yeah, then we just need to use the pull point component. We don't need this anymore. And we're just gonna use the points from both of our layers, you see, as the driving, let's say, factor, and those curves are gonna be the attractors. Well, the attractor geometry, which will control the rotation of our wooden bars. So let's say again we use the least normalizer. Spelling is terrible. Normalizer. Yeah, we normalize the distance from those curves to the wooden bars. We use the graph mapper. And it's not necessary right now, so I'm just going to keep it still. But yeah, but it's kind of nice to have this option to control these things. So let's use the bounds. Oh, sorry. Yeah. And let's construct the domain. And in this particular case, we're not going to use these curves to control the rotation. We're going to use them to control the amount of rotation. So not the angle, but like sorry, not the direction of rotation, but the angle of rotation. So how, to what extent will we rotate it? So we're going to keep it really, really low from 0.1 to 1. And this parameter we're going to use as a factor for the actual rotation, and the actual rotation is going to be generated, in our case it's going to be generated randomly. So we're gonna take it randomly. You see we have two shells, so it kind of makes sense to make sure that the bars in two shells will rotate in opposite directions, so that they kind of they crisscross and like they make these intersections. So we're gonna construct two different domains. Actually no, I'm gonna show you a smarter trick. I'm gonna create a domain. Actually, we can make a symmetric domain. Or no, sorry. 1 second, let me think. Let's create, let's say we make something like 30 degrees rotation, negative, and 0. So, and we merge this all, and basically we start the domain from -30 to 0 and then 30. We have 3 numbers, and then we can create, there is a default component in Grasshopper which can create consecutive domains from a list of numbers, right? So you just connect the numbers here, and then you go to additive and you right click and you say invert, so that it will basically create the domain from -30 to 0 and from 0 to 30, and then we graft it. So that we make sure, you see that we have we have a tree with 2 branches. Each branch like represents one shell, right? And now we have one single domain per one branch. So we have 2 domains for 2 branches. I'm going to keep this script on the screen for a few seconds so you can make sure you have everything in order, everything is corrected. Connected correctly, and then we will go on. So you can pause your video and make sure that everything is fine. Okay, I hope it was fine. So I mean, it was enough time for you to repeat this after me. So now I'm going to create enough values. So basically, we need to have one angle of rotation per one wooden bar, right? So that's why we need to know precisely how many elements do we have there. So let's just use the tree statistics component connected to to distance, and let's take the length of those lists, let's graft it, and let's connect it here. So now we have 180 values for rotation. Now we need to connect them here, but see what happens if we connect it like that, and if we use those planes as they are right now. You see that it's all like really, I mean, it doesn't look bad because the degree is like relatively small, but if we change 30 to something more extreme, you see it rotates too much, especially here closer to the edge. So what we're trying to achieve now, we are trying to control this rotation, and that's why we're gonna multiply it. These values we're gonna multiply it by those values from here, right? Based on the proximity to the initial curves. You see? Basically now these curves, they almost don't rotate, and those curves, they those lines, they start rotating a lot. And then if we want to make sure that we have even more control over this geometry, we can let's say we can say that we rotate them only close to the edges, right? And the rest will actually rotate a lot. So you see what happens. Now we have a very smooth silhouette on top, right? Because those lines, they almost do not rotate. And we have a very smooth profile close to the edge of our pavilion. But what happens in between is actually this overlapping that we were talking about. Yeah. Yeah, of course, we can also use some algorithms from Kangaroo to move the points from away from each other to make sure the bars in the same layer do not collide and so on. But this is probably going to be another topic for another time. Just it's always good to consider these things. Also, always good to consider how can you improve your script and how can you make it more like closer to reality, let's say. But right now, yeah, right now I'm quite happy with the results. For the concept development, I think for the concept design, I think it's fine. So yeah, let's put it a bit in order. Yeah, I'm also gonna keep this angle at 60, let's say, and I'm gonna increase the number of points even more. Yeah, this looks a bit more solid. Maybe we can decrease it a bit in the future, because now we are going to, instead of making the polylines, which were a nice representation, also quite a fast one, we're actually gonna make the wooden bars, which are gonna be represented by a very handy component which is called center box. Basically, it creates a box in a given plane with given dimensions. So for X direction, we're going to use 25. You see, so it already looks quite fine. Yeah. For Z direction, we're going to use this number which we used for the offset, which is 2.5. In fact, we need to divide it by 2, because the center box, it actually moves the geometry by this amount in both directions. Yeah, so we need to divide it by 2. And yeah, let's take this number, let's bring it forward, use it for Z, and then for Y we're gonna use, actually does it actually work like it should? Yeah, it actually does. It actually doesn't look bad. Just for Y, I'm just gonna use something higher. So let's multiply this number by, let's say, 2.0. So we have this decimal to control it a bit more precisely. And yeah, that's kind of it. Maybe 25 doesn't look that impressive. Maybe we can make it a bit longer. I don't know if 27 doesn't help or not, but maybe, yeah, maybe as discussed before, maybe we can keep it a bit lower, the number of points, number of bars, as follows. And we can also change the seed, so you see that we can kind of, we don't have much control over this change, but we can scroll to make sure we find the most optimal pattern that we, let's say, aesthetics wise, that's the kind of pattern that we like. Yeah. Okay, so let's hide everything except for the boxes. Let's create a B-wrap component, and now the last part, more like a bonus part, I'm going to show you the how to make a gradient to color code those bars. Let's make a nice image. So yeah, let's take something yeah, let's take the centers of those boxes. Let's deconstruct them. And now we're going to use a gradient to actually color code those bars. So let's say, yeah, let's say for the sake of also simplicity and to bring some more control over this, we don't want to make sure that every bar will be a specific color. We want to have, I don't know, let's say we want to have like 10 colors. So this gradient looks just fine to me. Let's create the bounds for the yeah, let's sort it along. Let's use the expression first of all, and then if you need to sort the points not only by X or Y or Z parameter, you can if let's say you need to sort them in three-dimensional space, what you can do, you can go to the expression and you can say you need to select the most important parameter. Let's say it's going to be z. You multiply it by 10,000 plus y multiplied by 100 plus x, for example, yeah. And then the points will be ordered in three-dimensional space, having the priority of being sorted by z, then by y, and then by x. Yeah, so you can sort them like that, or you can just use this combined parameter, like combine the total sum of this operation. You can use it to yeah, for the bounds, first of all, for the gradient. See, we have two layers, so we have two bounds, but they are quite similar because we use the same parameters to evaluate the bars. And it's also gonna be nice that we have a smoother transition between two layers. So let's deconstruct first of all. Let's deconstruct those domains, those bounds. Deconstruct the domain. We connect start to L0 and to L1. This, and then we connect these to T. And after that, we need to make sure that we have yeah, we just need to divide the domain. 1 second. No, sorry, not exactly. I mean, this we can also use this if we want to make sure that each bar gets its own color. We can make something like that, and this is also completely fair. So we can make it like this. You see, basically now each bar has its own color. With a lot of transitions, and in rendered mode it will look quite nice, I think. Yeah, but if we want to make sure that we have only let's say, I think it's going to be more visible with a simple simple gradient like that. You see that each bar is basically a shade of gray, or like, I don't know, a shade of orange, red, and green. You see, like here you can see the gradient. But let's say if I want to have only 3 colors or 5 colors from this entire palette, then we need to address this issue a bit differently. We need to we still need to take these parameters, and we need to take the bounds, but then we need to use the divide domain. Sorry, divide domain. Yeah, this one, and we need to define how many different colors do we want. I guess it's gonna be 5 or something like that. And then we need to do the same for this gradient. So we need to take this gradient, we need to create a range with only 5, actually not 5, but yeah, 5 values. So that x minus 1 here. Take those as t, as the parameter, and we use the same combination, but to deconstruct the domain from the range. So we take the bounds here. So by doing this, we get 5 different colors, right? These ones. Okay, and so we have 5 colors, and we also need to make sure that we have 5 different types of bars from here. So what we can do, we can actually yeah, we can actually just take this. We can say includes. This is an operation which basically checks if a certain number is included inside this certain domain. So we can use those ones as domains, and those values we use as to test them, basically. Yeah, like this. Now we take the call pattern. Also, it's important to graft those domains, but before doing this, we need to graft them here. It's going to be easier. I'll explain why in a second. Because we need to make sure that we have the same amount of branches. So here we're going to have 10 branches. Here we have only 2. We need to make sure that we use the duplicate data and we take the tree statistics. You see, we duplicate each of them 5 times, so we get 5 times more values than before. And then we need to partition list, taking the tree statistics from here and actually using the length of the list to sort it. So you see we have 10 branches here and 10 branches here. Yeah, like 10 branches here, 10 branches here. The difference is that each branch here consists of 200 elements and the branch here consists of only 1 element. And we're checking if one of those 200 elements, if it actually is included into one of those 10 domains. Yeah. And then we connect it to the pattern and we use the list from here. You see, we get 400 bars and each of them goes into one of the categories. So okay, let's take it. Yeah, here again we need to duplicate data. We duplicate it twice because we have 2 layers, right? So again we take the count, connect it here, and then we go for the partition list, and we take the list length. Why do we do it so in such a complicated way instead of just flattening everything and just sorting all the bars from the same list? That's a question that you might ask. Well, because what if we want to have different gradients for 2 different shelves, right? Or what if we assign a color as the attribute to our bars, but we also need to assign the number of the layer where it is located, right? So because we cannot, sometimes we need to categorize 2000 elements and we need to make sure that we know the position of each of them as precisely as possible. So let's say we have 2 equal bars. One of them is like shell number 1 green, the other one is shell number 2 green. They are equal, but they need to have holes or connections in different positions, right? So all these things they matter. That's why we try to that's why we're building those complex data structures, not for the sake of complexity, but for the sake of having more control over the design process and over the fabrication process later on. So okay, let's take those custom preview. Let's disable this one. Let's bring in another one. Let's use those materials and those bars. So there we go. What happened? From number to geometry. Ah, yeah, of course, because I connected the wrong thing. I should have connected those. Yeah, in fact, I should not have. Yeah, I should have done this, but I also should have done another thing, which is duplicating not only the numbers, but also duplicating the geometry, which comes from before. So the bars should be partitioned, and the bars should be called using this pattern. You see, now we get 5 clear colors. Yeah. Of course, sometimes the goal is to make sure our gradient looks as smooth as possible. So probably we might need to increase the number of colors. Yeah. You see, with this workflow, we can do all these things without having to redo anything in our code. We can just make. With 1 color doesn't work, but with 2 or 3 it starts working. Yeah, or more, of course. Yeah. I don't like this gradient that much, to be honest. I will change it to something more interesting as for my taste. By the way, you can also make your own presets here. So you can also take, let's say, I'm going to take this color, for example. Oh, no. this one. I'm going to change the color to something similar from similar to the preview. To the preview of this stream, I mean, let's say blue. Medium slate blue. Let's say I kind of like this color. Yeah, this one I'm going to change to something like green. Dark slate gray. Why not? Gray. Yeah. And this one I'm going to change it to something in between, let's say to something like dark sea green, or maybe something, I don't know, I don't have a really good taste for colors, I guess, but let's try to make it somehow appealing. You can like do the same thing with any other colors, of course. Yeah, let's say something like that. And maybe I'm going to actually reverse the list, because I want this thing to be darker on top and brighter, sorry, vice versa. I want it to be a bit brighter on top and darker at the bottom. I mean, to me this looks not bad, so let's keep it like that for now. And yeah, of course we can change the proportion of the colors. We can also change the position of the colors. Yeah. So okay, this is it. I hope this session was useful for you guys. Please let me know in comments if you would like me to maybe explain something more in detail, if you have any questions about plugins or something else in the following live sessions. If there are a lot of questions, we might be actually making a separate session answering the questions, so please don't hesitate to drop them in comments. If you would like to have a private or group course for Grasshopper or Rhino, also please send us a direct message on Instagram. You can find it in the description of this live session. I hope it was useful. I'm gonna keep the script here, and yeah, wish everyone a nice Sunday, and hope to see you all in the next sessions. Bye, guys.